So right now I want you to find the measures of MN, BC, and TU.
Like the line segment?
Mm-hmm.
Okay. Alright, well, NM is 2.6. Wait, are we doing this together?
Yes, let's go.
We're doing this together. I'm confused on B, though.
Yeah, I got 2 points.
Yeah, I don't know BC. I'm looking at all my... 38 is equal to 38. Right, but how... Oh, wait, that says 12. Never mind, it's 24.
It's 24. May have
My
magically
brain is
appeared.
Walter.
All right. And finally, we need to find TU. So how do we find TU?
Well, 3x plus 9 is equal to 7x minus 17. So then we do train track.
All right.
And I don't get B.
Okay, we'll talk about B in a moment.
12 is BD.
So Walter, if this
Yes.
is 12, and we know that these
Minus 6. Oh, wait, I didn't. Never mind. Never mind. I didn't realize minus 10, not minus 20. It's minus 17. 12. I'm sorry.
it's okay. All right. And so what is the measure of line segment TU?
I'm going. I'm going. Wait, Mr. Frankie. Ah! That ain't it.
It's not a typo. There will be a decimal, and that's going to be okay.
Okay. I'm only that ain't 4 over 26, 2 over 13. It's x6 by 13.
6.5.
Right? Maybe? Wait.
I got 6.5.
No,
You got x is equal to 6.5.
Yeah, and then
I got
Um,
4. I did it backwards. I got a 6.5 is equal to x, and 13 half. 6.5 is 19.5 plus 9 is 28.5, right?
28.5 is what I got.
There you go, 28.5.
I'm saying.
All right. All right, so using the angle bisector theorem, for example 2, what is the measure of line segment BC?
7.2.
7.2. So if this whole angle right here is 50 degrees, what is EFH? What is that measurement?
25.
25, because it's half, right? Okay. All right, and then finally, we know that these two segments are perpendicular and congruent to the angle legs. So what is the measure of angle MKL?
That's what I got.
Avery, do you agree with Walter?
Avery. Wait, yeah. Yeah.
Okay, so
I
yes, we
can't hear
agree.
anyone.
Okay, it is 38 because no one was speaking. All right, so
Okay, yeah. When you hear me,
all right, so
never mind.
all right. So we'll go with Walter. Walter wants to hang a spotlight along the back of a stage. Wires AD and CD are the same length, and A and C are equidistant from B. How do the wires keep the spotlight centered? Yes. You're being asked to make a proof.
That's kind of all right, kiddos, let's do this. Which proof, Walter?
Well, let's
I
do,
think I'm gonna do what you call proof, but let's make a plan first, Avery.
all right, so,
Could you just draw on the thing and say it's a coordinate proof?
well, that's the one way to do it. But before we do that, let's label this drawing with what we know to be true.
AD is
AB
compared to
equals
CD.
BC and AB equals CD.
Yeah. And then, couldn't you use one of the theorems
And
to
yeah,
say
angle
that
and
ABD is the right angle?
Wait, Mr. Frankie, also, yeah, never mind. DBC is a right angle, DA is a right angle, and angle A is equal to angle C.
So kind of what you're trying to prove is, if you can prove
That's the right angle.
that this is a right angle, then you've proved that the canister, point D, is directly under point B.
So we're not trying to prove that it's centered, we're trying to prove that it's under point B.
Well, that would be centered in this case. Centered is
Can we
direct.
prove that there's a dotted line that goes straight to B?
Can we use the converse of the perpendicular wait. Yeah, we could use the converse
Wait,
of the perpendicular bisector theorem
Oh, it's
to
the
say the perpendicular, and then the
perpendicular
perpendicular is the
bisector.
right angle.
You're trying to talk, shut up.
Claire, can you say that again?
Okay, we could use the converse of the perpendicular bisector theorem to prove that that AC or I that the two lines are perpendicular, and if they're perpendicular, then it's right angle. Okay.
Yeah, I agree.
Okay. Well, so we know that point D or CD and AD are equidistant, right? And so if the same point is equidistant from both sides of the line segment,
And it's on the perpendicular bisector.
then it's on the perpendicular bisector. That is right.
Wait, say that again?
So in the perpendicular bisector theorem, it says that if two lines are if 2 points, are equidistant, so here are the 2 points.
Oh.
Hello. Okay, if those 2 points are equidistant from the same point on a line, then that line is the perpendicular bisector of that line segment.
All right.
So that's how you do it. All right, and finally, for our last super fun task, write the equation in point slope form for the perpendicular bisector of the segment with endpoints of 6, -5 and 10, 1. All right, so what do we need to find in order to do this problem?
The slope.
We need to find the slope. What else?
We need to find this. We also have to find well, get this to court. Wait, don't we have to find y-intercept?
Well, we need to find the slope, but remember, we want the equation in point slope form. This is telling us that we don't need the y-intercept, but we want, but we want it to, and we want it to.
Wait, Mr. Frankie, sorry.
And so we want it in point slope form. The equation needs to be in point slope form. So we don't need to find the y-intercept, but we do need to make sure that this line that we're finding the equation of is the perpendicular bisector.
So do we find the slope and then find the slope of it, the negative reciprocal?
Yeah, so if we find the slope of the original line, you're right, the opposite reciprocal will be the slope of the perpendicular line.
Oh, we also have to use the distance formula.
Not the distance formula. So the perpendicular, we need the midpoint theorem. So we need to find the midpoint, because that's going to be our point, and then we need to find the slope of the original line, so then we can find the perpendicular line slope.
Well, the slope. Okay, so slope for Mr. Banky, y minus k equals m times no.
Yes.
Wait.
Yeah, you're doing good.
M
So
times it's m times. Wait, it's m times
now,
x.
so in a lot of books, in a lot of textbooks, you'll see it written this way. Where you have a point, x1 comma y1. But you're right. I preferred using two different.
Anyone else have 8 comma negative 2 for the midpoint?
I haven't done this
The midpoint is.
So while other people are finding the midpoint, Walter, can you tell us how to find the midpoint?
So you do 6 plus 10 over 2, comma, negative 5 plus 1 over 2. And then you solve that and you get 8, comma, negative 2. Yeah, I agree.
Yeah, I got that too.
Alright.
Okay. And so what about the slope of this line?
I found
The
negative
slope of the
2
sign.
thirds. Because I found the slope and then I found the
Okay, so the slope is, so the slope is 6, no, it's 6 over 4, yeah.
But then the negative
So
is
the slope's 6 over 4. And the value of y, so k is equal to, k is, negative 2, right, Mr. Frankie? For our equation?
Yes. Because
Wait, so y minus 8 equals 2 and x plus 2.
all right. So again, let's find the slope, right? So we have 1 minus negative 5 over 10 minus 6. So we get 6 over 4,
Yeah.
which is equal to 3 over 2. And so what is the slope of the perpendicular line? Negative
That's
2/3, right? So then we'll get our equation. So y
plus 2.
plus 2, because negative 2, find the opposite of negative 2. Our slope is going to be opposite reciprocal, so negative 2/3. And then we have x minus 8. And I will move that so it's more easily seen.
Wait, so h is the y comes before the x. I did it right. I'm so proud of myself.
Congratulations. That's cool.